Welcome to Module 11.6, Solving System of Linear Equation in 3 Variables. So in this lecture video, I'm going to show you how to solve system of linear equation with 3 different variables, x, y, and z. So there are several ways of doing on several different technique of solving linear equation with more than 2 variables. But I'm going to show y'all the most basic way using elimination method and substitution method. All right. So basically, I'm going to start out with 3 variables. So the first thing is selecting 2 equations and eliminate 1 variable by using the elimination or substitution methods. Select a different pair of equations and eliminate the same variable, because if I eliminate 1 out of the 3, then I will end up with 2 variables. So once I have 2 variables and 2 different equations, then I can use elimination or substitution methods to actually come up with an answer for 1 variable. And then once I come up with the 1 answer, then I can use back substitution methods to go back to the equation with the 2 variables to find the other one, and then take 2 variables, or excuse me, taking 2 answers and back into the original 3 variable equation to find the third one. All right, so let me show you how to do this. So this is the first equation, second equation, and the third equation. So the first thing you want to do, or the first thing we want to do, is pick a variable that you want to eliminate. So the way how I normally pick the variable is based on the coefficients of the variable. Just by looking at the multiples, basically. So I see the variable z has a smaller coefficient, so the multiples of 2, 5, and 3 is probably not going to be as big as compared to the variable for the y, coefficient for the x. Okay, so I'm going to eliminate z. All right, to eliminate z, I'm going to pick 2 equations first. So this time I'm just going to pick the first and the second equation. 2x plus y minus 2z equal to 4. That's the first equation. Then I'm going to pick the second equation. 6x plus 7y plus 5z equal to 1. So in order for me to eliminate the z, I need to make sure the coefficient of z are the same. So the multiples between 2 and 5 is 10. So I'm going to make my coefficient into 10 for the z. So that means my first equation, I'm going to multiply every term by 5 to make the second equation end up with a 10z. I'm going to multiply every term by 2. Okay. So let's see what I got. First equation, every term times by 5. That gave me 10x plus 5y minus 10z equal to 20. My second equation, every term times by 2. That's 12x plus 14y plus 5z, plus 10z equal to 2 times 1 is 2. All right, since the variable z has opposite sign, to eliminate the z, I will have to add them. So I'm going to add the 2 equations together. So that gives me 22x plus 19y. All right, the z gets eliminated, equal to 22. So this is what I'm going to call the new equation number 1. because this new equation number 1 consists of 2 variables. So now I'm going to pick 2 other equations so I can eliminate a z. And the reason why I got to do everything over again is because in order to solve for 2 variable, I have to get 2 equations. So this I'm going to pick first and the third. First equation is 2x plus y minus 2z equal to 4. I'm going to pick my third one, 7x plus 5y minus 3z equal to 6. All right, so I picked 1 and 2 earlier. I could pick 1 and 3, or I can pick 2 and 3. It doesn't really matter. The reason why I pick 1 and 3 because the multiples of 2 and 3 is only a 6. So I'm going to make them into 6z. So the first equation, every term got to times by 3. The second equation, to end up with a 6z, every term got to times by 2. Alright, so I should get 3 times 2x, 6x, plus 3y, minus 6z equal to 12. That's 14x plus 10y, minus 6z equal to 12. Alright, so since the z has the same sign, I'm going to subtract. As a matter of fact, I'm going to take the bottom one, subtract the top one. So 14 minus 6 will give me 8x. 10 minus 3 is going to give me 7y. And the z actually get eliminated. Same thing, subtracting cancels out. Equals 12 minus 12 is also 0. So this is my new equation number 2. So now I'm going to line up my 2 new equations so I can decide to use elimination or substitution methods. So substitution or addition method is basically used when none of the coefficient in front of the variable is 1. Just like in this case, there's no way I can make them into 1. So this time I'm gonna just use elimination. So for I can either eliminate the x or the y. I'm gonna do y. I'm gonna eliminate y now. Alright, because the common multiple between 19 and 7 is 19 times 7, which is 133. So I'm going to multiply every term in my new one by 7. Second, the new 2 times every term by 19. Alright, so let's see. This is a lot of computation. 22 times 7, 154. So that's 154x plus, what did I say, 133y equal to 154 again, right? 22 times 7 is 154. 19 times 8, 152. X plus 133y equals 0. So since the y has the same sign, we will subtract. I'm going to take my top one, subtract the bottom one. So the y will cancel out. 154 minus 152 is 2x equal to 154. My answer, divide both sides by 2. 154 divided by 2, 77. So x is 77. So now I can take this same x equal to 77 and do some back substitution. I can go back to my new 1 or new 2. So new 2 looks easier, so I'm going to go back to new 2, okay? So sub x equal to 77 back to new 2. So that will be 8 times 77 plus 7y equal to 0. So 8 times 77 is going to be 616. Go ahead and move that 616 over. The 7y equal to negative 616, right? It was positive here. Move over, become negative. Divide both sides by 7. My answer y equals negative 88. So now I got x and y. I can back substitution back to the original first, second, or the third. So it looked like the first one is the easiest one. So there's 2x plus y. So there's 2x plus y. What was it? Minus 2z equal to 4. So now I'm going to substitute the x I just found and the y I just found in here. Let's see what I get. 2 times 77 plus negative 88 in a parenthesis minus 2z equal to 4. I'm going to go ahead and put this in the calculator and see what that is. 2 times 77 plus negative 88, or you can say minus 88, same thing. 66. So that will be 66 minus 2z equal to 4. I'm going to move my negative 2z to the right, become positive 2z. At the same time, I'm going to move my positive 4. I'm going to move my positive 4 back to the left side. That becomes 66 minus 4, which is 62. Divide both sides by 2. That will be 31. So basically, 3D variable is referring to 3 dimension. So the point of intersection in this 3 dimension object is going to be at 77, negative 81, and 31. Okay? So 3 variable is referring to 3D. 2 variable, like we done before, is referring to the 2 dimension, which is your x and y axis. All right. So let's try another one. I know that was a bit much. So remember now, the very first thing is to pick the variable you want to eliminate. So you really got to look at which one is easier to eliminate. So in this particular example, again, my variable z has coefficient 311. So that seems a little bit easier. So I'm going to eliminate my z again. So I'm going to pick the first and the second. So first equation is not, if I pick first and second, I want to eliminate z, that means the second equation got to become a 3z by every term times by 3. Because a common multiple between 3 and 1 is 3. So the first equation, we don't have to multiply any number because the z is already a 3 there. So that's negative 5y plus 3z equal to negative 1. The second equation becomes negative 9x plus 6y plus 3z equal to 3. So now, since my z has the same sign, we will subtract. So I'm going to take my top, subtract the bottom, okay? Negative 5 subtract negative 9. In your calculator, it should be 4x. Negative 5 subtract a 6 is negative 11y. 3 minus 3z cancels out. Negative 1 minus 3, negative 4. So this is going to be my new equation number 1. All right. So that was me picking first and second. So now I'm going to pick the second and the third and eliminate z, because since the coefficient is already the same, then I don't have to multiply anything. So this is my second equation. This is my third one. So since a z has different sign, we will add them for the z to be eliminated. So negative 3 plus 2 is going to be negative x. 2 plus 1. 2 plus 1 is positive 3y equal to 1 plus 3 is 3. So there's my new 2. Okay. So let me line this up, okay? So my new one is 4x minus 11y equal to negative 4. My second equation, my new 2 is this. So I'm gonna since my new 2 has a coefficient 1, I'm gonna solve for that x in new 2. So negative x go to the right side, become positive x. Move the positive 3. Move the positive 3 back to the left side. That's 3y minus 3. So let's call this new 2 prime. Because in a minute, this is where I will come back to get the value for x. So now I'm going to sub new 2 prime into new 1 for every x I see in new 1 for 3y minus 3. So that will be 4 times parenthesis 3y minus 3 minus 11y equal to negative 4. So that's 12y minus 12 minus 11y equal to negative 4. So that's y equals, combine like terms, 12y minus 11y is 1y. Negative 12 move over, become positive 12. Negative 4 plus 12 is 8. So my y is 8. Now I'm going to sub my y equal to 8 back into my new 2 to the x. So that will be 3 times 8, 24 minus 3, which is 21. So x equal to 21. So now I got 21 and 8. We can go back to the original first 3 equation to find z. So it looked like the third one looked the easiest. So I'm going to do the third one. So the third equation is 2x plus y minus z equal to 2, right? So now I'm going to say 2 times x, which is 21, plus y is 8 minus z equal to 2. So quickly, 2 times 21 plus 8 is 50. So 50 minus z equal to 2. Move the negative z over, move the 2 back, put z equal to 48. All right. So that's it. My point intersection, 21 is x, y is 8, and z is 48. Okay. That's my point of intersection between the 3 lines in 3 dimensions. All right. Let's try a couple more. Just kind of get an idea what's going on. It's very repetitive procedures. Before you do anything, you look at the coefficients to determine who is easily to be eliminated. So it looked like x is actually not that hard to eliminate. It looked like z is actually pretty easy. So since I did z twice, I'm gonna do x this time. Okay, it doesn't matter who I eliminate first. The answer will always be the same. So I'm going to eliminate x in this particular example because I know the common multiple between 1, 3, and 6 is only a 6. So it's not that big. So if I pick the first 2 equations, first, I want to eliminate z, eliminate x. I need to make the x the same. So the common multiple between 1 and 3 is 3. That means the first equation, every term times by 2, times by 3, so I can end up with the 3x as well. So that will give me 3x plus 3y plus 3z equal to 6, right? My second equation does not change, still the same. So since my x are the same sign, we will subtract. I'm going to take the bottom, subtract the top. 3 in the bottom, subtract 3 on top, cancels out. 5 in the bottom, subtract the 3y on top is 2y. 4z in the bottom, subtract the 3z on top is positive z, equal negative 6, subtract the 6 on top is negative 12. So that's my new equation 1. All right, now let's pick 3 and 6. How about that? 3 and 6, second and third equation, because I need to come up with another one. So if I eliminate x, then my equation should only have y and z. So we got to make sure the first two things we do is eliminate the same variable. Pick 2 and 3. All right, to make the x the same, the common multiple between 3 and 6 is 6. So that means my first equation, every term got to times by 2. So I can end up with a 6x at the beginning. So my second equation now will be 6x plus 10y plus 8z equal to negative 12. My third equation does not change because it's already 6x. All right, since the x has the same sign, we will subtract. All right, I'm going to take the top, subtract the bottom. So the x will cancel out. 10 minus 3y is 7y. 8z minus 8z minus 4z is positive 4z equal negative 12 minus 1, negative 13. All right, so that's my new equation 2. All right, now I'm going to line up my two new equations. Ooh. So I see my new 1 does have a coefficient 1, so I can solve for that variable z. Now, if you choose to do another elimination, you can. I just more favorite substitution methods, because substitution method is quicker. I don't have to, make numbers bigger. So let's solve for this z in new 1. So that will be z equals, move the 2y to the right side, that's negative 2y minus 12. Call this the new 1 prime. Now I'm going to substitute my negative 2y minus 12 for every z I see in the new 2. So that would be 7y plus 4 times negative 2y minus 12 equal to negative 13. Right? New 2 was equal to negative 13. That's 7y minus 8y minus 48. Quick distribution equal to negative 13. So 7y minus 8y is negative y minus 48 equal to negative 13. So I'm going to move my negative y to the right. Move my negative 13 over, so that's negative 48 plus 13. So that gives me negative 35 for y. All right, now I'm going to sub my y equal to negative 35 back into my new 1 prime so I can find z. So my z is negative 2 times negative 35 minus 12. So z equals negative 2 times negative 35 minus 12. 58 Couping. All right, so I got y and I got z. So let's go back to the original first 3 equations. The first one looked the easiest, right? X plus y plus z equal to 2. So I'm going to use that first equation to find my x. So x plus y plus z equal to 2. So let's substitute. So x plus y is negative 35 plus z is just straight up 58 equal to 2. So positive 1 times 35 is negative 35. So I get negative 35 plus 58, that's 50. So x plus 50, hold on a minute, negative 38. Negative 35 plus 58, sorry. Negative 35 plus 58 is positive 23, sorry. So x plus 23 equal to 2, move the positive 2 over. So that gives me x equal to negative 21. All right, so my answer, point intersection, negative 21, comma, negative 35, comma, z is what? 58. All right. Now let's look at a couple more examples, okay? These are for no solutions and infinite number solutions. I want to show you what they look like on paper. During the arithmetic, what's going to happen. So I'm going to eliminate x again. And this is real neat. First, second, and third. All right, I'm going to pick the first 2 real quick. In order for the x to be the same, the first equation got to times everything by 2. So I'm going to quickly do it right here. So my first equation now will say 4x plus 2y minus 10z equal to negative 4. All right, second equation does not change. Negative 4x plus 4y minus 6z equal to 3. If I add them, all right, x has different sign, I got to add to eliminate. So that will give me 6y. Negative 10 plus negative 6 is negative 16z equal to negative 4 plus 3, negative 1. All right, that's my new equation number 1. Now I'm going to pick 2 and 6. Excuse me, I'm going to pick the first equation and third equation. So when I pick first and third, that means I need to make the x to be 6. So the first equation now will times everything by 3. The third equation is not going to change. So that is still 6x minus 3y plus z equal to negative 7. First equation now would be 6x plus 3y minus 15z equal to negative 6. All right, let's eliminate x. Since x has the same sign, we will we will subtract. Same sign, we subtract. So check it out. 6 minus 6, x will cancel out. 3y minus negative 3 is 6y. Negative 15z minus 1z is negative 16z equal the negative 6 minus negative 7 is positive 1. So what do you see between the two new equations? See, it almost looked like if I lined up the two new equations here, the y and the z has exactly the same sign. So if I subtract them, all the variable term will cancel out, just like when we did with the two variables. So this is actually 0 equal to negative 2, which you know that cannot be true. So this problem is telling you there are parallel lines, so there's no solution. Okay, that's what it looked like. Arithmetic-wise, this is what it looked like. So for a problem that have infinite number of solutions, then your new one and your new two should be exactly the same. As you can recall, the y-intercept here is different. The slope is actually going to be the same. Okay. If we would treat the z is like, if we treat the z like the y, treat the x like the x. All right. So let's take a look at this one. This one, I think I'm gonna do the y this time. Eliminate the y. So I want to make the y the same. So I'm going to pick the first two first. So in order for the first two equations where the y is the same, which I'm going to make them into 12, the first equation every term times by 4. Second equation every term times by 3. So I can just make my mark like this and begin to work. 4 times negative 7 is negative 28x. 4 times negative 3y is negative 12y. 4 times negative 3z is negative 12z equals 4 times 4 is 16. Second equation. 3 times negative 3x is negative 9x. That's negative 12y. That's negative 15z equal to 0. So the y has the same sign. We will subtract them. So negative 28 subtract negative 9. Negative 28 subtracts negative 9. That gives me negative 19. All right, the y cancels out. Negative 12 subtract negative 15 becomes negative 12 plus 15, which is positive 3z. 16 subtract nothing is 16. All right, so that's my new one. So now let's check out the eliminate y. So I'm gonna do the second and the third this time. If I pick second and third, make the y the same, that means my third equation, everybody got to times by 4, because the common multiple between 4 and 1 is 4. So the second equation does not change. All right, let's see what happens here. Third equation, that will be 16x minus 4y minus 8z equal to negative 16. Since the z has the same sign, we will subtract. So if I take the top, subtract the bottom, negative 3 subtract 16 is negative 19x. Negative 4 subtract negative 4, the y cancels out. Negative 5 subtract negative 8 is positive 3z. 0 subtract negative 16 is positive 16. So do you see my new 1 and new 2 are exactly the same? So since they are exactly the same line, that means all three lines are exactly the same. So they intersect infinite number of times. So this problem is infinite solutions. All right. That's what it looked like arithmetic-wise. All right, one last one. This one is a little bit bizarre. Missing some variables here, but it doesn't make it harder. It actually makes it a little bit easier. So if you look at it though, if you look at it, the first two equations, see the z already the same. So if I will eliminate z in the first two equations, what will happen right away? So x plus z equal to -6, right? So since I'm missing the y in the first equation, the reason why I'm missing the y because my y is a missing term, as you can recall. Well, we will talk about this in a different module. Missing term means the term has a coefficient 0. So I write it down so you can see when I need to subtract or add, I need to use that 0 as a placeholder. So the second equation is really saying 0x plus 1y plus z equal to 8. So I'm trying to eliminate z. So z has the same sign. We will subtract. So when I subtract, x minus 0, or 1 minus 0 is 1x, but 0 minus 1y is negative y. Z cancels out. -6 minus 8 is -14. So this is my new equation number 1. It is interesting though, because if I eliminate the z, the only variable I got left is x and y. At the same time, my third equation only has x and y. So now I can actually line up my new one, which is x minus y equal to -14, with, I can line up my new one with my third equation. And since the coefficients are all the same, I'm just going to do another elimination. So this time, I'm going to eliminate the y. We'll have different signs, so I'm going to add them. Or I could subtract the x to eliminate x. But I want to do the y. So that's 2x, y cancels out, equal to -8. So x equal to -4. All right. So now I got my x equal to -4. I can substitute back into my first equation up here to find z. I can substitute my x equal to -4 to the third equation to find y. So x equal to -4 back to the first equation to get z. X plus z equal to -6. X is -4 plus z equal to -6. So move the -4 over, become +4. So -6 plus 4 is -2. Now I'm going to sub x equal to -4 back to the third equation to find the y. So that will be x plus y equal to 6. X is -4 plus y equal to 6. So y is equal to 10. -4 go over, become positive. That will be 10. All right. So my answer. Please be careful, okay? When you enter your answer on the homework, make sure you x, y, and z. So that's -4, 10, and -2. All right. So this lecture video, I show you how to solve linear equation in 3 variables simply using the substitution and elimination method. So there are other techniques we can do this, but for the restricted time frame we have, I think learning using substitution and elimination method is actually the quickest. All right, that will conclude this lecture video. Thank you for watching.